Hi, I'm Dion from leavingcertmathsvideos.com. Now the first part of this question we're asked to express A in terms of K. So basically what we're going to do is we're going to find the slope first. So the function x is defined by x squared plus k, so we're going to get the slope of that. F times x is equal to 2x. But we also know at the point A, we want the slope at the point A. So what is the slope of the point A? So we'll just fill that in for x. So the slope of the point A, slope at the point A is equal to 2a. But we also know this, that if we draw a line out here, now the slope of that tangent is always the y value over the x value. So as in tan of the angle. So tan of theta is always equal to the slope of a line. So here we have the slope of this line here is equal to FA over A. So 2A is equal to FA all over A. Now F of A, that applies 2A is equal to F of A, which is A squared plus K all over A. So now we're looking good here. So that implies that 2a squared is equal to a squared plus k. And that implies a squared is equal to k. And that implies that a is equal to the square root of k. And that's correct. Now for the next part of the question, we're asked to find the area bound between the curve and the two tangents. And we're asked to leave that in terms of k. So what we're going to do straight away is we're just going to redraw the graph again. We just redraw this graph. And here is our slope here, and here is going to be one tangent, and here is going to be our other tangent. Now what we have to do here, we have to find the area of this shaded area here. Now we're asked to find it in terms of k, so we're better off starting in terms of k rather than in terms of both terms. So this here was a comma f of a. Well, we know that a is equal to root k, so that's the same as root k. And our f of x, that was equal to x squared plus k. So then our f of root k is going to be 2k. So let's move all that out. So there's the point, root k comma 2k, that's our point here. Just draw that triangle down here now. Now, as we see the area, don't forget this is symmetrical as well. That's the main. That's one thing you remember, is just to make it handier. Now, what we could do here, we could find the integral from minus root k to root k, and then subtract the area of the two triangles. But what you're better off doing is finding the area of just this one triangle and double it, because that means your limits will be root k and 0 rather than root k and negative root k. So we'll just line this out now properly. Implies the area, just write it down in English first, is equal to twice area under curve under one curve, say, one curve, minus twice the area of a triangle. So the area under the curve, that is equal to the integral from root k to 0 of our function was x squared plus k. So we're asked to do it. So twice that. So twice the integral from x squared plus k. So basically we're finding the integral of this shape here on the right hand side. And we're saying twice that is the area of all this underneath here. So then we have to subtract the area of the two triangles, which is going to be reasonably easy. Minus twice the area of triangle A. Well, triangle A is equal to half the base times perpendicular height, which is half, well in this instance we just use half 2k. It's equal to half 2k, which is k, times the height, which is root k. or times the length. Basically I'm using half the y value here times the x value. So it's half 2k times k, which is k root k. Which is reasonably straightforward. And we're going to integrate this. That's equal to twice brackets x cubed all over 3 plus kx. And that is where it bounds from root k to 0. Now, when we fill in 0 here, it's just going to all equal to 0. So it's just basically twice the integral of this when root k is filled in our x terms, minus 2k root k. So we just fill in here, that's equal to 2 times root k times root k is kh, so that's k root k over 3 plus k root k. And that's minus 0, don't forget, minus 2k root k. Now, what we can take out here, we can take out a factor of root k because that's common in both. So that's equal to 2 root k, or sorry, 2k root k. 2k root k into the third plus 1 minus 2k root k. Now, we can also take out 2k root k as a factor here. So that's equal to 2k root k into a third plus 1 minus 1. So it's equal to a third. So that implies the area is equal to 2/3 k root k. And that is the area bound between the curves and the tangent of the curve there. So basically what we did here is we got the integral of this triangle here. We got the area of this shape here. And then we doubled it. So then we got the area of this shape, or sorry. When we got the area bound underneath the curve, we got the area of all of this here. And then we doubled it, so that means we got the area of all this here. But we want the bound area, so that means we have to subtract these two triangles here, which is what we did. And all that, and in the end, we got our answer to be 2 root 3 k root k. Alright.